It's in their pocket right now. It knows where they slept, who they texted at 3 a.m., every place they walked today. The phone is the witness that never sleeps, and on Android, almost every secret it keeps is stored in the same place. A SQLite database. Welcome to Android Forensics. Master a handful of file paths and one bridge tool, and that pocket-sized witness will tell you everything. Know the stack, bottom to top. A Linux kernel at the base, which is why low-level acquisition needs root. The Android runtime, ART, executing DEX bytecode, native libraries, and SQLite lives here, everywhere, the framework, then the apps, and wrapped around all of it, the security model. Every app sandboxed in its own Linux process, with a unique UID. SELinux enforcing mandatory access control, and file-based encryption on by default since Android 7. That sandbox and that encryption are exactly what you're fighting to get under. 4 ways to acquire, and they are not equal. Logical, ADB backup, no root needed, but it's the shallowest, missing, deleted, and system data. File system, ADB with root, the full user partition, every app database. Physical, JTAG, chip off, a raw NAND dump, the deepest, recovering deleted files from raw flash. And cloud, pulling synced Google data. The rule to burn in file system acquisition requires root. No root and you're capped at a logical backup. When the phone won't cooperate, won't boot, screen locked, you go to hardware. JTAG, solder to the debug interface and read memory directly. Chip off, physically remove the NAND flash chip and read it in a specialized reader. Destructive, the last resort. IESP, solder to test points, less destructive than chip off. And EDL, emergency download mode, a Qualcomm low-level mode that advanced tools exploit. From gentle to brutal, JTAG ISP, then chip off. ADB, the Android debug bridge, is your lifeline, and it needs USB debugging enabled. The first command of every case, ADB devices -L, confirm the device, get its ID, then ADB shell to get inside, ADB pull to copy a database straight out, /data/data, package name databases, ADB backup for a logical capture, producing a .ab file you must convert before reading, and ADB logcat-d, dump the system log, forensic gold for app activity during the incident window. Devices, shell, pull, backup, logcat, now the treasure map, and it's one path repeated, /data/data, package name /databases, memorize it. Every app's private SQLite lives there. The system databases you must know by name, mmssms.db for SMS and MMS, telephony.db for the call log, contacts2.db for contacts. Pull mmssms.db, open it in SQLite 3, query the SMS table. Type 1 is received, type 2 is sent. The messages are right there in plain rows. Timestamps will trip you if you're sloppy. Android databases store time in Unix milliseconds. Milliseconds since 1970. Divide by 1,000 to get standard Unix seconds, then convert to a date. Get that wrong and your whole timeline is off by a factor of 1,000. And don't forget the cloud half. A Google account syncs Gmail, Chrome, photos, and location history. Google Takeout exports all of it, with credentials or with legal process through Google. The device and the account work both. Found a suspicious app? An APK is just a zip archive. Unzip it and look inside. Android manifest.xml declares every permission. A flashlight app asking to read SMS and contacts is your malware tell. Classes.dex is the compiled code. Run it through jadx to decompile straight to Java source. And meta-inf, CERT.RSA, the signing certificate. The same certificate across multiple apps means the same developer. That cert links a malware family to one author, anti-forensics, the factory reset, the suspect's favorite. But NAND flash doesn't instantly overwrite. so remnants can survive in unallocated space, and the deleted contacts table may still hold soft deleted entries. Except, and this is the modern wall, on Android 6 and up, encryption is default, and a factory reset rotates the key. Physical acquisition of an encrypted reset device gives you nothing but ciphertext. And the tool that ties it all together, SQLite UFED, the industry standard for Android and iOS. Android forensics in one breath. Almost everything is SQLite at /data/data package databases. File system acquisition needs root. No root means logical only. ADB devices -L starts every case. mmssms.db is SMS. Telephony.db is the call log. Contacts2.db is contacts. Timestamps are Unix milliseconds. Divide by 1,000. APK is a zip. JTAG decompiles it. CERT.RSA links the developer. Factory reset plus default encryption equals ciphertext. Cellebrite UFED is the standard. Next up, Objective 14.2. iOS forensics, where the exact file names are the exam. 3 to go.